So we knew this design would be successful because we designed it around the model for a slingshot. By cocking back the centerpiece, we knew that we would be able to project the ball to some distance. How far we would be able to project it would depend on the angle we released it at and how far we cocked it back. All of this theorization was based on our personal experience. The angle we released it from and the distance from the slingshot band determined how the ball would be shot.
When we started off, we had a different design entirely. However, it wasn't strong enough at all, so we thought up a whole new design. The actual structure we thought up didn't change at all, but the angle of the clip needed to be adjusted a few times to get the ball into the hula hoop. Also, the bands were not taut enough, so we made them tighter so the ball would go farther.
When we took the calculations, we went to my house and set up the projectile on the length of my street. We placed the garbage bag underneath the apparatus because the ground was wet from the rain. We drew a line of chalk in front of the projectile right at the base and used the measuring tape to measure 20 meters, which was 65.62 feet, to the hula hoop. The measuring tape was only 30 feet, however, so we made tick marks at the end of each 30-foot mark with the chalk until we measured out the correct distance. We placed the hula hoop over the X and measured 44 centimeters from one side of the hula hoop to the center of the hula hoop to be sure that it was perfectly centered.
Then we made 4 tick marks with chalk around the hoop so that if the hoop moved, we'd be able to replace it without measuring again. PJ was the one to set the project and release the balls. Vivian and I stood beyond the hula hoop to catch the bouncy balls once they made contact with the ground. PJ used his phone to time the total time it took before the ball came in contact with the ground. Vivian and I would tell him if the ball made it inside the hoop, which determined if it could be data or not. We laid a meter stick in the hoop and estimated the distance of the balls from the center of the hoop to find the distance from the apparatus to the point of contact.
So this is the data we collected from the methods previously explained. We found the velocity of each trial and the average of the time, displacement, and velocity. Of course, this is only the horizontal velocity. We also used a protractor to find the angle of launch from the horizon to be 39 degrees. Using the angle of launch and the horizontal velocity, we set up our vector diagram like this. Using our knowledge of trigonometry, we used SOHCAHTOA to find the y velocity and the resultant velocity. This is how we found our resultant velocity, horizontal velocity, and vertical velocity.
Just a small town girl living in a lonely world. She took the midnight train going anywhere. Just a city boy.
This is on our physics report.
What? Wait. Who lives here?
Me.
Really?
Yeah.
Oh, don't put this when you